Welcome to my video on one-sided and two-sided limits. In a previous video, I defined the limit as x approaches a of the function f of x equal to L. It goes to a specific value, a real value. So what this implies to us implicitly, we did not actually give it, is that both of it comes in from the left and the right. It squeezes a. So I'm going to draw a graph to show you that. There's the x-axis, there's the f of x axis. Here's our generic curve here. This is our point A. What this tells us is we're coming at it from the above and below, the smaller numbers, meaning on the x-axis here, and from the larger values x. This was the case for x greater than a. So this is what this implies. We're coming at it from both angles when we have just a regular limit. Now, if we wanted to find a two-sided limit, this is where we come at from the left and the right, and we get possibly different numbers. And that's what we're going to show here. Sometimes they're not the same number. It doesn't go to the same L. So from the left hand, that's going to be x is less than or equal to a. And in this case, we are going to use this notation right here, a minus or a plus, or whatever that number happens to be, a 1 or a 5. We put a little minus sign or a little plus sign next to us. That tells us a limit is coming either from the left or the right, meaning the upper numbers, x greater than a, are from the left, x less than a. I'll draw a graph to kind of illustrate that. F of x, here's our function. There's our a value again that we're trying to find the limit of. So what this tells us is this a minus comes at it from the left or the lower values of x, and this a plus limit is defined as coming only from the right side. So these are two separate limits, and we're going to see in just a second in a theorem that if they converge, then we do have a defined limit. So here's our theorem. As x approaches a, the limit of f of x is L. That's just like what we saw in the very first slide. If the limit from the left exists and the limit from the right exists, and both limits are L. So let's write that out in a kind of a formula. So if the limit x goes from the right for f of x is equal to the limit x comes from the left, or vice versa, you can switch that around, of f of x is equal to L, so they're both equal to L. And then what we can say is the limit for x going to a, and this is from both sides, notice there's not a plus or a minus here, of f of x is equal to L. So essentially what we've done, we've squeezed this limit from the left and the right, and if they converge to the same number L, whatever that number might be, then we can say that the limit as x goes to a is equal to L. Next, I want to look at an example. So let's look at the function f of x is equal to x plus 2, and that is for x less than 1, and it's equal to 3x plus 2 for x greater than or equal to 1. So that's the function. So let's graph this to get visually an idea of what's going on here. X-axis, the f of x. Now it's going to be discontinuous here. So we're going to do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we're going to do -1 and -2. So there's going to be our XY coordinate system. So let's plot this first one first. X plus 2. So let's look at x equal to -2. So now we're going to x equal to -2 for this first function. X plus 2 is equal to 0. X equal to -1. It's going to be equal to 1. X equal to 0, it's going to be equal to 2. And then at x equal to 1, we really don't know, but it's going to be close to 1. We can kind of say that. So this is going to be a line, and we expect it to be a line because it is in the form of y is equal to mx plus b. Remember, that's our equation of a line. Slope, y-intercept. So our y-intercept, so that makes sense. Now, let's look at the second one. So we've got 3x plus 2. So let's start at 1 because 1 is allowed. So that's going to be 3 plus 2. That's going to be a 5. X equal to 2. 3 times 2 is 6 plus 2 is 8. So there's 10. So there's 8 at x equal to 2. Now x equal to 3. We got 3 times 3 is 9 plus 2 is 11. So at 3, we go up here to 11. So we have another straight line, but it's got a different slope. It goes off to infinity there, goes there. So our point now is we're trying to figure out this region around 1. That's kind of our area of concern right in here. What happens to this limit in this region where it changes? It's a jump continuity. So now let's do our squeeze play with this left and the right limit. So first of all, the left-hand limit. Let's calculate that. So the limit is x goes to 1, and that's from the minus side. Notice the little minus there in the 1. That tells us the left-hand limit. We can evaluate it at 1. So that's 1 plus 2 is equal to 3. Now let's evaluate the right-hand limit. So we have the limit as x goes to 1 from the right side, coming down this way. That is going to be equal to the function evaluated at 1, which is going to be 3 times 1, which is the x now, plus 2, and that is going to be equal to 5. So our two limits coming from the left of 3 and coming from the right is going to be a 5. So those are not the same. 3 does not equal to 5. So that implies, since the limit x going to 1 minus does not equal the limit of x going to 1 from the right, implies no limit exists. It's just undefined. You've got a big jump continuity right there, and so it's just undefined. Well, I hope you got something out of this video, learned a little bit more about limits, and I want to thank you for watching.